In this video, we are going to be talking about the industrial preparation of hydrogen. So you can take this video as a part 2 of the preparation of hydrogen. Okay, the preparation of hydrogen. You can look up on the video which I previously made on how you can prepare hydrogen in the laboratory, and that's the one which I took as a part 1. So this is more like a part 2 of the preparation or preparations of hydrogen, and this one is going to be done in the industry. Okay, this one is going to be done in the industry. So how exactly does this all happen? Okay, how exactly does this all happen? Well, this industrial preparation of hydrogen may be done using 2 pathways. So the hydrogen gas may be produced using 2 pathways in the industry. Namely, there is what we call steam reforming. Okay, steam reforming reaction. Some other textbooks can call this reaction as natural gas reforming reaction or gasification. These are the other terms which can be used synonymously with steam reforming. So if you want, you can say steam reforming. If you want, you can say natural gas reforming, or if you want, you can say gasification. Okay, gasification. And the other pathway which we can produce the hydrogen gas in the industry is this reaction which we are calling as the water gas shift reaction. Okay, the water gas shift reaction. Now, anytime you hear steam, steam just refers to water in gaseous state. And anytime you hear natural gas can refer to simple alkane gases. And one of those gases which we can get might include methane. And this is the methane that you're seeing here, the CH4. So natural gases just include simple alkane gases like methane. You can also get ethane, which has C2H6 as the chemical formula, and we can also get propane, which is like C3H8. These are other examples of natural gases from which we can obtain our hydrogen. Okay, from which we can obtain our hydrogen. So natural gas, these are just like simple alkane gases, which might include methane, whose formula is going to be CH4, ethane, whose formula is going to be C2H6, and propane, which is just going to be like C3H8. Okay, so what exactly is involved in steam reforming? What equation can we use to summarize this steam reforming reaction? Well, anytime steam reforming is taking place, as said, natural gas is reacted with high temperature steam. Okay, natural gas is reacted with high temperature steam. So we are not just getting ordinary steam here. We are saying that we are reacting this thing with high temperature steam. When you're talking about rates of chemical reactions, you're going to see that one of the ways in which you can increase the rates of a chemical reaction is by increasing the temperature of the system in which the chemical reaction is taking place. And once you increase the temperature, what is going to happen is that the kinetic energy of the reactant particles is also going to increase. And once the kinetic energy of the reactant particles increases, there will be a very, very high efficiency of successful collisions that are going to take place, causing a high number of products, molecules to be formed. Okay, so anytime you want to increase the rate of a chemical reaction, one of the ways is by just increasing the temperature. Increasing the temperature increases the kinetic energy of the reactant particles. If the kinetic energy of the reactant particles has been increased, there will be a very high rate of collision between those reactant particles, and more product particles are going to be produced within a short period of time. That's the whole reason why we're not just getting ordinary steam here, we're getting high temperature steam, so that the rate of this reaction can be high. So as said, natural gas is being reacted with high temperature steam, and this is what we have. So I have gotten methane, and methane is being reacted with water. And once methane is reacted with water in a gaseous state, we're going to see that carbon monoxide and hydrogen gas are going to be produced at the end of the day. So if you don't want to use methane, like I have said, you can get ethane and propane. It's your choice. But one thing that you need to know, that regardless of the natural gas that you take, the products will always be the same: carbon monoxide and hydrogen gas. Now, in this reaction, one of the key things that I want you to see is this thing here. You're going to see that there are two arrows here. There is this top arrow, which is representing a forward reaction, and then there is this arrow pointing backwards that is showing a backward reaction. Anytime you're going to see these arrows, then just know that that given chemical equation or that given reaction that you have is a reversible reaction. So this steam reforming reaction, in which natural gas is being reacted with steam at very high temperatures, is a reversible reaction. This is a reversible reaction because there is this arrow representing a forward reaction, and then there is this backward arrow that is showing a backward reaction, of course. So a forward reaction is a reaction in which reactants react to form products, and then this backward reaction is just more like a reaction in which the products change back into the reactants. Okay, and if I interest you in what we call chemical equilibrium, chemical equilibrium will only be established if the rate of forward reactions is equal to the rate of backward reactions. So this whole reaction here is a reversible one because of these two arrows. So anytime you see these, then you can be very well sure that what you are having is a reversible reaction. Now, these two reactions, steam reforming reaction and the water gas shift reaction, always work together, like they are consecutive. Steam reforming reaction firstly takes place, and then this water gas shift reaction will take place afterwards. If you notice, you're going to see that the carbon monoxide in the steam reforming reaction is going to be taken again, and it's going to be reacted with steam to produce extra or additional hydrogen. Okay, so not water, produce additional hydrogen. This is the whole reason why you're going to see carbon monoxide plus H2O forming carbon dioxide and hydrogen gas. And just like steam reforming reaction, the water gas shift reaction is also a reversible one. So this is just a summary on how we can prepare hydrogen in the industry by the steam reforming reaction and by the water gas shift reaction. Steam reforming reaction comes first, the water gas shift reaction comes second. They are both reversible reactions. These two reactions can occur at high temperatures so that the rate of chemical reactions, the rate of these reactions can also increase. And that's it for this video. This is how we can explain the industrial preparation of hydrogen.